Hello, so today we will talk about ratio test. It is just simple as any values if limit of n to infinity of a of n plus 1 over a of n absolute equal with L. If L is smaller than 1, then the series of a of n is converge. If L is bigger than 1, then the series a of n is diverge. And if L equal 1, then the series a of n inconclusive. By that you have to test for other series test. Some signatures to recognized ratio test, such as the series contain factorial. For example, n of factorials mean n times with n minus 1 times with n minus 2 times n minus 3 infinity, or n plus 1 equal with n plus 1 times n times with n minus 1 so on more, or 2n is just equal with 2n times with 2n minus 1 2n minus 2, or 2n plus 1 factorial, which is 2n plus 2 factorial, so that we have 2n plus 2 times with 2n plus 1 times with 2n times with 2n minus 1 times 2n minus 2 so on more. Also, that is might have some things like the series which contains k of p over p of k, or series of p of k over k of p, as k is the unknown and p is any constant. For the first question 1, k equal 1 over k factorial. Apply a ratio test. We have limit of k to infinity of absolute of 1 over k plus 1 factorial times with k factorial over 1. How can I drive to this answers? It's just limit of k to infinity of absolute of 1 to the k plus 1 factorial over 1 over k factorials. So I flip it this side and this one back side, so it's derived at this answers. By that I know k to infinity of k times with k minus 1 times with k minus 2 so on more, over k plus 1 times k minus 1 times k minus 2. This is the values for k plus 1 factorial, and these are the values for k factorials. The numerator cancel with the denominators. By that, it left out with limit of k to infinity of 1 over k plus 1 absolute, which is 0. It's less than 1, so we can conclude the series is converged. Question B. Series of 2k times 3k over k factorial. So this series is equal with 6k over k factorials. And then you can try again, limit of k to infinity of absolute of 6k plus 1 over k plus 1 factorials divided by 6k over k factorial. So I just want to explain more about why do I got k plus 1 in these areas. So in case you don't know, just a of k plus 1 is just equal with all the values of k, you change it to k plus 1. For example, a of k equal with 10k plus 10k squared. Then ak plus 1 equal with 10 times 1 plus k plus 1 plus with 10 of k plus 1 squared. By that, I have this limit as limit of k to infinity as absolute of 6k times with 6 times with k factorial over 6k times k plus 1 factorials. This one will be cancelled. Then once again, limit of k to infinity of absolute of 6 over k plus 1, because k's factorial divided by k plus 1 factorials gonna be k plus 1 only. This one equals 0, smaller than 1, so the ratio test for the series is converged. Similarly, if it is just like plus 1 over here, so this one is just the series of 2k times with 3k times 3 over k factorials. And then you're just doing the same step, just like times 3 over here, times 3, times 3. And then this one is times 3, so this one 18, and still go to 0. Another question is C. Series of infinity to k equal 1 of 2 to the k and k to the 4th. When you see some series, such as the constant a to the k is the unknown over k to the unknown a, you can use ratio test. Or the series with the unknown k to any constant over any constant to the k. We'll also use ratio test. By that, we use ratio test for these cap examples. By that, limit of k to infinity of 2k plus 1 over k plus 1 to the 4th times with k to the 4th over 2k. So this one cancel out, this one equal with limit of k to infinity of k to the fourth over k plus 1 to the fourth times 2 equal with 2, since limit of k to infinity of absolute of 2k to the fourth over k plus 1 to the fourth equal with 2. Because I choose the highest exponent right here is 2k to the fourth, and then the highest exponent over here gonna be k to the fourth only. So that is gonna be limit of k to the infinity of 2k to the fourth over k to the fourth, which is 2. So the answers, the limit of k to infinity of a of k plus 1 over a of k equal to bigger than 1. So based on the ratio test, we have it as diverge.